Hi, welcome back to the shop. Today we have a new project. We are making a sine base for the small toolmaker's vise. I often have the need to make angular cuts on small workpieces, and they have to be pretty accurate. Mostly on my current project, the miniature M1911, there are a lot of angled parts, so normally I take this small grinding vise and adjust it with a sine bar or with the protractor in the bigger vise, and then I clamp it up, but that's not very accurate, and it's a bit you need 3 hands most of the time for this operation. So I decided to build a base for this vise to be bolted on. This base will be wider than the vise itself, so it can be clamped in my big milling machine's vise, and it will have a half circular contour, and there will be 4 holes for dowel pins in it, and they will act like the rollers on a sine bar. So you put a pin in here and in here, and you have a length of exactly 60 millimeters between those 2 pins, and you can stack up gauge blocks on the 1 pin to set your angle. You can calculate the angle, or you can use a sine table. You stack the gauge blocks under this pin, and then you clamp the whole assembly at the right angle given by the gauge blocks in your big vise, and you have your desired angle. You can also mount the vise in that direction to tilt it sideways with this base. Also, you can put a pin in here and in here to mount it like that, to mount it upright and tilt it away from 90 degrees. So this should be pretty versatile, and I'm looking forward to build this. My first problem was that this small grinding vise didn't have these slots. They weren't there. This vise was plain all around, so there was no way to hold it down on this base. They just went on and machined these slots into the hardened vise. This vise is about 55 Rockwells hard, as you can hear. A needle file just skips over it. So I have some footage of the slot cutting. Okay, fixed jaw and the movable jaw are on this vise is ground together, so they are the same height, and I can use the movable jaw as a spacer when I clamp it up in the vise like this. Yeah, always drop your parts. Also, I'm setting up my stop here. And using my small edge finder to catch this edge of the piece. Okay, I'm catching this edge and this edge. This is a 2-flute coated carbide end mill made by Mitsubishi for machining hardened materials. as you saw, this wasn't too bad. In the end, I took a depth of cut of 0.5 millimeters with 4000 RPM and a feed 50 millimeters per minute. So that worked fine. The end mill is still cutting, and I got some very nice blue chips. Okay. I got the slot on the first side roughed out, and I'm going to turn it around to rough out the other side. And first I'm going to rough out both sides, then I'm changing to another end mill and finish these slots too. Okay, I'm setting up to finish the slot. This time I'm using a 3mm full flute finishing end mill. I'm going to full depth, and I'm running it at 4000 RPM with a feed of 200 millimeters per minute. I'm using my new Toyo disc mics. And we hit our 4 millimeters pretty good. So that's it. Now this vise has 2 slots to clamp it down on the sides. Now we're going to make the actual base from this piece of 123/12. That's a pre-hardened free-cutting tool steel for mold making, and I like this stuff very much. It's pretty tough, and also it machines very nice. It gives good surfaces, it machines very well on the shaper and on the milling machine, and it's durable. So, and also I have a good amount of material of this. I have a good amount of this stuff here. Yeah, let's get started. First we will have to true up this block on the shaper. Okay, we're over at the shaper, and first we are going to true up this block on 3 sides. We will start with this big side surface that we're going to reference off the other 2. And here I have the tool bits I'm going to use. I will bring you a bit closer and show them to you in detail. Okay. Because I often get questions how my shaper tools look. These are the main 2 tools I'm going to use. This is a straight bit for roughing. That's what we're going to use for the heavy material removal. And this is my finishing bit. It's a shear tool. It has a big radius on the bottom ground on. A lot of side rake, about maybe 25 degrees, and not so much back rake, maybe 5 degrees. And this works only with a very shallow depth of cut, but with a high feed or infeed. It will give a very nice finish and it can take off a shaving that's only 1/100 of a millimeter thick. So these are my 2 shaper tools I use most of the time. Okay, now to set up the piece in the vise, we put 2 parallels under it, and these 2 sides are rough sawn. This is sawn, and this is also sawn. This looks like from a bandsaw, and therefore it's pretty uneven, and I'm going to put some brass shim stock between the jaws and workpiece. That will compensate for some of the irregularities and help me to clamp the piece securely in the vise. Found some shim stock. And as I just noticed, the rotary base of the vise is not clamped. Okay, these are snug. And now we can clamp it down. Give it a good clamp. First we will begin with our roughing tool. I have the pull type clapper box mounted. That means the cutting action is in this direction, and it will clap away and work like this. I prefer the reversed clapping box for most of the work, because it gives me the capability to take a heavier cut, and also the chips don't fly all over in the shop. Clamp it down. Okay, this tool leaves a pretty rough finish. As you can hear, when I move my fingernail over it, it's like a file. So we change over to our shear bit, the tool with the big radius on it. And I just go down by a bit over, I'm going down 1/10 of a millimeter, and I'm putting on some cutting oil. Because even if that stuff is free cutting, it's still tool steel. So a bit of cutting oil will help. And as you can see, we get a very nice surface right now, and also we get very fine chips here. Okay, that's the finish we get with this shear tool, and I bring the camera around, and as you can see, this is really a fine finish. My finger even mirrors in the freshly machined surface. The best thing is if you take a machinist straight edge. This is a blackout flat surface. And that's the reason why I love this shaper that much. Okay, we have the first side flat, and now we need to square up the second side. I'm going to rest the machine surface against the fixed jaw of the shaper's vise, and we're going to clamp it against it, and then we're going to machine the top surface. Because this jaw is square to the machine's table, this surface will automatically get perpendicular or square to the other already machined side. The only problem is that this side is still rough and it's a solid surface, so if we clamp now, the part could tip around, tilt, or even walk out of the vise or be pushed out of the vise. So we're going to use a ball bearing to give us 3-point contact. We are clamping here on the whole surface, or on these two ends. We're bearing on the whole surface, but for explanation we think of only these two sides. And if we push now in the center here, it will contact the fixed jaw in a very safe manner. And to do this, I have this ball bearing with a ground flat on it. The ground flat goes against my movable jaw of the vise, and the spherical surface of the ball bearing goes against my workpiece. This is a bit tricky because it is a ball bearing and therefore it's round and it always wants to drop down, but I put a tool bit down there to hold it up while I'm clamping. As you can see now, this ball bearing pushes against my workpiece, and the workpiece is pushed against my fixed jaw, and I have a safe clamping setup to work with. The flat on the ball bearing isn't really necessary, but I put it there so I don't have the spherical surface of the ball bearing pushing against my nicely ground jaw, and I don't want to have imprints of a ball bearing in it. So ground the flat on it and good to go. I got this block squared up on this 3 sides, and now the task on hand is to cut this slot lengthwise and this slot across it. This will enable me to mount the vise on this block in that direction and in that direction. The whole pattern to clamp the vise down will be the same in both directions, so I can use the same clamping pieces in that direction and that direction. Also, I have drawn on where the pin holes will go. They will be drilled and reamed to 6 millimeters. This is the main pivot. Around this, the whole thing will tilt or can be tilted in the vise, and then you can choose where you want to put your second pin. Here, here, or here. If you put it here and here, you can tilt it that way. If you put it here and here, you're going that way. And if you're putting a pin in here and here, you can tilt the assembly that way. Or if you put gauge blocks under this one, you can go opposite, that direction. And that gives you all possible ways to reach almost every angle you want the vise to be. And to make it look nice, we're going to machine a nice round curve on the bottom of this base. But now we're going to machine this slot. Okay, right now I'm setting up to machine the slot for the vise, and I have my super sensitive 1000mm dial test indicator out, and I'm checking if the part is level in the vise and also if my alignment in that direction is correct. Adjust it to 0, and as you can see, this is really very touchy. And now I'm going to hand crank the machine. We're at 0 and we're going forth, and we got some chittering of the needle, and we're dropping it jitters about 0.02 of a millimeter, so that's fine. That's more than okay. This vise will almost exclusively be used for small parts, and 60 millimeters, 0.02 of a millimeter, that's fine. Now we're going to check for alignment in this direction. Okay. Brought the camera over so you can see, and again I'm adjusting to 0, and okay, that vise is absolutely not adjusted. So let's loosen the bolts and get it right. Okay, let's see. Ooh! Oh, that was the wall cam. Such a sensitive dial indicator can be a real bitch to work with. Okay, that's okay. Now we clamp it down very carefully, not to move the vise. We start at 0 and we jitter about 2,000, so that's okay. Okay, now I'm setting up for cutting the slot. I have my slotting tool. In fact, it's ground like a parting tool on a lathe. I have it set up, and now I need to get it straight. And to do this, I will look on the back side against the bottom cutting edge of the tool, and I will look along it like on a gun sight and check the light against this setup block I put here. And if the light between the setup block and my cutting edge is even all the way along, my cutting edge is level to the workpiece. Okay, here is the cutter, and this is my setup block, and you can see down here between the cutter and the setup block, which is in fact an old gauge block, and there's a line of light. That line of light is constant over the width of the tool. So if I slightly bring that out of adjustment and bring it down again, you see now the line of light is heavy on the right side, and I know that my cutter is not level to the surface. With the checking against light, you can get your alignment down to hundredths of a millimeter or 0.5 of an inch. Just okay. Now we're back to level. Okay, I just laid out the lines where to cut to give me a hint, and also I touched off on the surface. As you can see, I'm just scraping along the surface of my workpiece. And as we see, this tool holder does not work with the pull type or pull action clapper box, because when it tilts away, it grabs and breaks the cutting edge. I never realized that. I never used this style of tool holder in the backward clapper box. So that was a short visit of Mr. Bozo, and now I have to regrind my tool, mount the other clapper box. I regrind the tool, mounted the push type clapper box, and set the cutter up again. So let's go again. Okay, that was my first slot. Now it's just a matter of hogging out the material between the two lines and then finish it to final size. I just set it over almost the full width, and there we go again. Okay, that's it. Now the slot is roughed out to 1.4mm depth. Next we're going to finish it to width, and then we'll do a finish cut on the bottom, but that's for the next installment of this project. So far, thank you very much. See you next time.